let's suppose that you think interest rates are going to rise. You're the treasurer at a firm, a company, finance specialist, and since you think interest rates are going to rise, that you want to hedge some of your existing floating rate interest payments. Specifically, you want to use a swap to effectively swap your floating interest rate payments for fixed. So what you want to do, ideally, is have something that effectively you pay a fixed rate. You want to lock an interest rate in, but as part of this swap, which is the way you're going to effectively construct a fixed interest rate, you're going to receive a floating payment. The payment that you receive, this floating payment, is going to be linked to LIBOR or some other index, and that's going to rise and fall as interest rates in aggregate rise and fall. So the idea with a swap is that today you're locking into this additional contract where every 6 months, or however the terms are constructed over every periodic period, you pay a fixed rate, no matter what interest rates do. As part of this swap contract, you agree to pay a fixed amount. And that doesn't change for the life of this entire swap contract. That stays fixed. I mean, that's kind of what you're trying to achieve. But as part of this swap, you pay something and you get something in return. You receive a floating payment. The amount that you receive every 6 months or whatever varies. It floats. And it varies according to whatever interest rates are doing in the economy. And if this is the swap contract, the nature of the swap contract, the idea is that you use this swap contract, you structure it such that it kind of mirrors your underlying bond payments. So your original bond contract in this example is that you have it for a finite duration and make sure that these durations of the swap and the duration of your bond match. But just as part of that bond payment, you have to pay a floating rate if this is a floating rate bond. So whatever you pay your investors, the people who bought these bonds from you, it varies according to what interest rates are doing in the market. So that's the risk, is that you just don't know what this bond is going to cost you as a company. You may have gotten a cheaper interest rate as a result, but that interest rate could end up rising significantly if interest rates in the economy rise significantly. And so we're going to use a swap contract structured such that it's kind of mirrored, it's got the same maturity and the same payment frequency as your underlying bond, so that we can synthetically construct a fixed rate bond. And it sounds complicated, but it happens a lot in practice. And the reason that it happens is that oftentimes you can get a interest rate that is effectively fixed, but constructed using these two contracts together. And that interest rate, though fixed, is going to be cheaper than if you had simply tried to go to a bank and get a fixed interest rate, a simple fixed interest rate up front. Or if you had tried to go and sell bonds out in the market and it was a fixed interest rate bond. So this can be a way to raise debt more cheaply, as well as to hedge risk if you have expectations about interest rates in the market in the future that are changing. That is, if you fear interest rates are going to rise. For example, we have a variable interest rate loan, and we want to put a swap on. We want to swap for a fixed interest rate. And as part of that swap, we're going to pay a fixed interest rate and receive a floating payment. And we're going to take that floating payment and use it to offset the floating payment that we pay on the bond. That is, we already have this bond here. What we're going to do is we're going to pay this extra amount on this swap, a fixed rate amount, but the floating payment that we receive, we actually receive money from that swap, we're going to make it such that it's enough to pay the floating amount on our underlying bond. And this floating amount on the swap is going to be linked to interest rates. So if interest rates rise, so does the cost of our payment on our bond. But then again, so does the payment that we receive from this swap contract. So no matter what interest rates do, even if interest rates rise, for example, we'll receive enough from our floating component of the swap to offset that higher cost on our underlying bond. And the net result is that we just pay a fixed interest rate. So let's say, for example, this bond that we pay, whatever we pay each year, it's LIBOR, it's whatever interest rates are as far as being referenced to LIBOR, plus a spread that's specific to us, 2.5%. So we pay LIBOR plus 2.5%. Whatever that is total is what our annual interest rate payment is for this bond. And in fact, if LIBOR is currently at 2.35%, then if we consider the cost of LIBOR plus the cost of our spread, our total interest rate for this bond right now is 4.85% per year. So, for example, if we had $5 million of these bonds outstanding, our annual interest payments would be $242,000. And that's fine, but what happens if interest rates rise? That is, suppose LIBOR goes from 2.35% to 3.85%. That is, it rises by 150 basis points. So interest rates have risen by 1.5%. That means the total cost of our loan now, we still pay that 2.5% fixed spread, but the total interest payments on our loan are now at 6.35%. And so our $5 million notional principal, the amount of bonds that we have outstanding, multiplied by this new interest rate of 6.35% per year, means that our annual interest cost in dollar terms is $317,500. And so you can see, as the interest rates in the economy have risen, the cost of this same bond has risen as well. It's risen by this difference here. In this case, it's $75,000. So interest costs have gone up by $75,000 per year here with this bond. But that's without a swap. That's just the raw cost if interest rates rise for a floating rate bond. But if we had bought a swap during this time when interest rates were still 2.35%, where we pay a fixed rate every payment period and in return receive a floating rate that's linked to LIBOR. So suppose that this swap specified that we had to pay a fixed rate of 3.75% every period, but we would receive LIBOR, whatever that was at that time. We can then go back and analyze what that effect would have been on net, this swap and bond combined. First, looking at the bond, we pay LIBOR, and we still pay our credit risk premium, our credit spread. That's that 2.5% that you see on the left. And we don't receive anything from the bond. But if we look at the swap component, this swap over here, what we pay on the swap is a fixed rate, and we don't have any credit risk premium as part of the swap, but we receive LIBOR. And so you can start to see the pattern here. If we pay LIBOR on the bond, but then we receive LIBOR on the swap, then these two cancel out, and the net effect is that we are still stuck with paying the credit spread. There's no way to hedge that out, and we make a fixed payment. So whatever LIBOR does, if we get a swap, it no longer matters, because here LIBOR is a payment, and here LIBOR is a receipt. So putting numbers to this, if we look here at the original interest rate, what interest rates were at the beginning, 2.35%, and that's what LIBOR was at the beginning, 2.35%, and our credit spread was that 2.5%, and then that's all we pay, and we don't receive anything from the bond. But as far as this swap, we bought this swap on top because we wanted to hedge out our LIBOR risk. We pay 3.75%, a fixed rate, no credit risk premium involved with the swap. And in return for paying 3.75%, we pay LIBOR, which is that current 2.35%. And if you look at the total, 4.85% payments on the bond, plus a net cost of 1.4% on the swap, then the total cost of the bond and swap combined is 6.25%. And so certainly you're paying a premium here, the 6.25% versus what you could have had if you had remained floating of 4.85%. But let's see the benefit as a consequence of paying that premium. The benefit becomes apparent as interest rates rise. So as interest rates rise, if you had remained unhedged without a swap, you would be paying 6.35%. But as far as the swap is concerned, when interest rates rise to 3.85%, the bond becomes more expensive, certainly because you still have a floating rate bond. It's just that you've synthetically constructed a fixed rate. So you still make higher payments to the bond holders. Now it's that 6.35%. But if you look at the swap, you still have to pay that fixed payment. That was agreed up front, and that stays fixed by definition. But you receive 3.875%. You receive whatever LIBOR is. And so here, you're actually receiving money at this point from the swap. You're receiving a net 0.1%. And so your net cost, bond and swap combined, if you look at these two together, is still exactly the same. And so if you've hedged it right with this swap, that is, if you've bought a $5 million swap, a swap with a notional principal of $5 million, because that's the size of your original bond issuance, then you can look at the effective cost of swapping into this fixed rate, synthetically constructed fixed rate security as showing an interest payment effectively of $312,500. And you can see then the relative benefit of hedging with the swap by comparing this $312,000 to the payments that you would have otherwise had to be making if you had remained unhedged with this floating rate security, $317,000. In this case, with interest rates rising and you choosing a swap, it looks like you saved $5,000.